Notice, the contents of this video are only for demonstrational purposes. Devices, techniques, and lockout-tagout procedures can vary significantly from facility to facility. You should adhere to the lockout-tagout training you receive at your location. Every Berry site has an approved lockout-tagout policy and program that you will be required to know and understand. In real-life situations, every step you see in the demonstration would be followed by test, try, and verify. Verifying that the potential for unexpected release of hazardous energy has been eliminated. Test, try, and verify.
Okay, so we're just going to go through some of the most common scenarios that you're about to find on the floor, in a typical factory floor. The lockout, tagout, some people have some experience, some people have no experience. So this is just to give you a quick rundown as to some of the more common devices and how they work. So we have an electrical disconnect here. We have a circuit breaker box here with circuit breakers, just like you would find most likely at your house or apartment. And then we have a typical cord. We have a plumbing scenario with a ball valve, and we have a quick disconnect air fitting that would most likely be on a machine. So we'll start here. Power is in the on position right now. If I want to go work on that machine, and it said I needed to shut the power off, this is where I would do it. Now I could go work on the machine and verify the electricity is off. However, this doesn't keep somebody from coming up right behind me and turning the power back on, putting myself in danger. So I could take a hasp, I could take a lock, and one of my tags, and I would lock this, take the key, put the key in my pocket, and now it's impossible for somebody to come over here, see this, and not know that this machine is locked out. There is my name on there. They know who to go see if they have a question. And there's the danger. Both sides of the tag make it very, very clear that there's a problem here. Don't touch. So once it's safe to do so, I would take my lock off, take the hasp off, and then if it's safe to do so, turn the power back on and we could run that machine. Here, if I was required to, I would turn my breaker off, and then I have one of these devices which is designed specifically for breakers that clips on there, and then I would take my lock with my tag and I would put it through there, take my key, put my key in my pocket, and now I have this circuit breaker completely locked out. Very, very obvious once again that nobody should come along and turn this power back on. So this is another very common scenario. Once it was safe to do so, I would take my lock and my tag off, and I would remove this, and I would then be able to turn my power back on. This is a cord or a plug. This is one of the few exceptions to the lockout tagout in some cases. If I'm working on an appliance where this is the only source of power and I am in sole control of this plug, I don't have to have it locked out. However, as soon as I go on break, go get tools, as soon as I walk away from this and leave this, then I'm required to make sure that I'm trying to keep everybody else safe. So as soon as I am not in control of that plug, then I have to lock it out. I can put my hasp on there, take my tag and my lock, lock it, take my key, put my key in my pocket, and nobody's going to be able to come along and just plug that in and hurt themselves or somebody else because that piece of equipment wasn't ready to be started yet. Also, the reason for these hasps, this provides 5 other people a place to put their lock. If Joe comes over and Joe wants to help me, Joe can come over, put his lock next to mine, and now he has his lock for protection, I have my lock for protection. When Joe leaves, Joe takes his lock, and then when I'm done, I take my lock, remove it, take my hasp, remove this, and then I'm able to get back to whatever I was doing. There's also different size plugs and cords, and that's how devices like this come into play. So this would obviously be for a significantly bigger cord and plug. So just the same thing, different size. Here we have a plumbing example. So right now this ball valve is aligned with the pipes behind it, which means it's in the on position. That would be off, on. If I was required to turn this off to do whatever work I needed to do, again, I would need a way to prove that it needed to be off, show it needed to be off, and then find a means to make sure that it stayed off. I could do the same thing, my lock and my tag, and now that valve is in the off position, and until I take my lock and tag off, it stays there. These can also be used if it was important for this to be in the on position while I was doing my work. Then you could also use this, oops, in this position the same way as the off position. Once I was safe and I was done, then I could reestablish whatever position I needed to. There's many different size ball valves, so they make a lot of different size of these. So this one happens to be very large for this valve, but it's able to accommodate a lot of different situations. So, and just like the other one, it's also able to accommodate a situation where, just like that, where the valve needs to stay in the on position. Here we have a quick disconnect valve air line here. They have these little adapters, which that one actually is too small. That one fits on good. Now this won't work with a hasp. You actually need the diameter of a lock for this device to work like it's designed. But you put your lock through there with the tag on it, and now that can't come off. I got my lock with my name, I got my tag with my name, and it's very obvious to anybody who walks up here that there is a reason for that. Once I'm safe and I can remove that, then I would take my lock off, pull that off, take this off, and the air could be reattached to this.
Lockout, tagout, eliminating the potential for the unexpected release of hazardous energy.